Here we are, part 14 of the stock pot refining series. And what I'm doing here throughout this entire series is trying to get those metals concentrated. And in part 13, you've seen we got some of the copper out of there. I got a response back from a YouTube viewer whose channel is Aquila Refining. I recommend you go check him out. He's got some good stuff on his YouTube channel. But he recommended that I boil the black powders in hydrochloric acid for about an hour. And this should take all of the copper out of my PGMs and leave just the platinum group metals behind. So now what I'll try to do is get some of the copper out of my mixed black PGM powders with hot hydrochloric acid boils. By the way, if you go check out Aquila Refining channel on YouTube, I believe that he is set up to do toll refining. And he'll treat you right, treat you fairly, and do a good job for you. If you've got some metal that you want refined, check with Aquila Refining. Okay, here we go. Part 14 of the stock pot refining series. Okay, I'm going to start by vacuuming the solution off of the mixed black PGM powders. I'm going to drop a stir bar down in the beaker. You can see there's a piece of undissolved zinc there. Put this up on the stir plate here. Turn the stir bar on. Now I'm going to add some hydrochloric acid here to try to dissolve out any remaining zinc that's in there. The zinc is reacting with the hydrochloric acid that I added, and I want to get that out of there first before I go to the hot hydrochloric acid boil. So I don't have any heat on right now, just the stir bar to get the zinc out of there. Here you can see those pieces of zinc dissolving from the cold hydrochloric acid here. I'm going to wait till all the bubbling stops. That will indicate that I've got all the zinc out of there. And then we'll let this settle, decant off the solution, try to rinse the powder one time, and then we'll go with the hot hydrochloric boils to remove copper. Silver cell's been running out for 3 or 4 days after I cleaned it out, and I just wanted to give you a peek of the crystals growing in here. And they're getting pretty close to that anode basket, so what I'm going to do is take this rod and knock those down in there, get them away from the anode basket, because if they contact that anode basket, it'll cause a short circuit through the cell and burn a hole through the anode filter and then contaminate my batch of silver. I have to run it back through the cell a second time. This is the impure silver. I'm going to go ahead and refill the anode basket here with some more impure silver. The cell consumes about 5 troy ounces of impure silver per day and turns it into pure silver crystal down inside the silver cell there. should do it. This has been on stirring now with the hydrochloric acid for several hours, and I'm still seeing it's like a piece of zinc back here. I think I still got zinc in there, so I'm going to add a little bit more hydrochloric acid. Keep stirring for a while. Putting in a little bit more hydrochloric acid. Solution's been on stirring now for about an hour and a half. I'm going to turn the stirrer off and we'll let this settle and see what we got in that solution there. I've got a tall 600 ml beaker here. Got the weight written on the side. I'm going to transfer the solution out of this beaker here into this so it can settle and I can get the solution out of there easier. First, I want to get the stir bar out. Cover on here now. We'll let this settle and then I'll get the solution off the black mixed PGM powders. I allowed this solution to settle overnight and it's got a little bit of an orange tint to the solution above the black PGM powders. I'm going to get a stannous test on that. I'm going to reach down into the jar there and get a little bit of the solution on a piece of filter paper here, and then we're going to test it with stannous chloride testing solution. See if you got anything going in the solution there, and I don't see anything. No reaction, so it's safe to conclude that there's no precious metals in this solution. I'm going to vacuum it off and get it off of the top of the black powders down at the bottom of the beaker now. Transfer the black powders back into this larger beaker now. And we'll start the hydrochloric acid boils. I'm going to put the stir bar back in now. Set this back up on a stir plate and get stirring. Now I'm going to add hydrochloric acid and we're going to boil this solution, or boil these black powders with hydrochloric acid, see if I can get some of the copper out of there. I'm going to reach in there and get a temperature reading now so we got a baseline. And it looks like we got 23.6 Celsius, 74.5 Fahrenheit. I'm going to turn the heat on here to about medium high. This scale goes up to 7, so I'm putting it on 4. See if we can get this stuff to boil, get some of the copper out of there. Alright, the mixed black PGM powders have been boiling now for a few minutes. They've been on there for about a half hour now. And we're going to let this go for about an hour. And we'll turn the stirring off, let it settle. We'll test some of the solution, see if it's got copper in it. The black powders have been boiling in hydrochloric acid now for about 15 minutes. I turned the heat up to high, and as you can see, I got a nice rolling boil going. We'll just let this go for about another 45 minutes, and then turn it off and let it settle. My mixed black PGM powders have been on a rolling boil now for about an hour. Let's turn the stir bar off, turn the heat off, and I'm going to pull this off and let it cool down for a little while. Then we'll take the stir bar out and transfer it back into this tall beaker. I'm going to get the stir bar out now. Now we'll transfer that hot solution into this tall beaker. Putting it in this tall beaker helps when I go to decant the waste solution, because it decreases the surface area of the metals, the black powder, and forms a taller column that's easier to remove that liquid. Oh yeah, that powder, that black powder is looking real good now. Just kind of wanted to get a close-up of how much different that black powder looks now. It's looking fluffy and clean. I'm just going to let this all settle out. I probably could have just decanted the solution right there. See how fast that's settling now? That's what I want to see. All the solids are just drifting down to the bottom of the beaker. I can probably go ahead with the tests on this solution now. First thing I want to do is a stannous chloride test here. It's a piece of filter paper on the end of a bamboo skewer. Make sure we don't have a whole bunch of precious metals in solution. And that test is negative. Got no indication of precious metals in solution. Now I'm curious to see if I got any copper in solution here with that hydrochloric acid boil. So to test that solution, what I'm going to do is I'm going to put a little bit of distilled water in this little beaker here. And then I'm going to get a little bit of the waste solution off the top of the PGM powders here and add it to this solution. And now I've got some 10% regular old household ammonia, and I've put some in this little dropper here. It's full of ammonia out of this bottle, and I'm going to add it to this solution and see if it turns it blue. See what happens here. If it turns blue, that means I got copper in solution. And there it goes. I see a little bit of blue color going on there. I'm going to add right out of the bottle here. I do see some blue color going on in there. I'm going to add a little bit more of this ammonia. Oh yeah, see that? That blue color is an indication of copper in solution. That hydrochloric acid boil appears to have produced a good result here. That blue color in that test solution indicates I've got copper in solution, which is what I was after. Over here, the PGM powders down at the bottom of that beaker look nice and fluffy. It's settled quickly. So now what I'm going to do is decant that solution and start rinsing the black powders off. Alright, this copper solution, I'm just going to go ahead and put this down into my waste treatment bucket down here. Alright, in case you're wondering what I had going on here in the back of the fume hood, this is some gold that I had quarted, that I was parting out the silver and the base metals with dilute nitric acid, and I'm about ready to pour that off and begin dissolving that. But that's a different process than what we're doing right now. What I want to do now is focus back on my PGMs here. That solution is still kind of warm, but the powders are nice and fluffy now, and they hold together well. So I think rather than using a vacuum to siphon this off, I can just pour this solution off into my waste container here without pouring the black material, the black PGM powders from the bottom of the beaker. And once I get this poured off, what I'm going to do is start rinsing it with some hot distilled water until I get all the waste solution rinsed off of there. It's looking good. I've got some hot distilled water here. I'm going to add a little bit, do some small rinses here. Hopefully, if this stuff down here, the black powders, are in the state that I want, this will settle out right quick after I put this water in. I'll just keep rinsing it until I get all the waste solution rinsed out of it. Look how fast that settles. That's what I want to see. Alright, if you look at this beaker here, it's got a brown liquid in it. And if you remember earlier in my series, I tried to use some sulfuric acid to get the copper out of there. I was looking for a green or a blue color, but I think that brown color right there is the copper. So I just wanted to show you how quickly this stuff settles now. It's at the right state of where I want it to be. I can just pour it off without any of the black PGM powders coming over. And then I'll just keep doing this and keep rinsing it. Watch how quickly this the solutions, the powders settle. This is hot distilled water I'm pouring in here now. And you'll see that it settles very quickly. See that? See how quick it settled? And that's a good sign that we've got some clean black PGM powders down in the bottom of that beaker. This will be about the 5th rinse that I've done with hot distilled water. And what I want to do is just reach in there with a pH test strip here, a rough one, and get some kind of idea what the pH is. And it's looking like it's down around 1, maybe 2. So I'm getting the acid out of there, which is what I want to see. This is rinse number 10, distilled water rinse number 10. And I've got pH of about 4 there, looks like. I'm shooting for pH of 7, which is neutral. And that'll mean I'll have all the acid and dissolved copper out of that solution. Alright, this is rinse number 20. Hot distilled water rinse number 20. What I'm going to do is stick my my little pH test strip down in there now. Should have it pretty close to neutral. And let's see, where we at with this thing? I'm going to call it neutral. We're at pH 7, easy. Maybe just a little under. But I think we're going to be good here. That was it took 2,300 ml rinses to get all the acid out of that solution. Okay, I've got it all rinsed out. It took 20 rinses. Now what I'm going to do is pour off this final rinse here, and then we'll put the beaker up on some low heat and evaporate the powder to dryness so that we can get a weight on it. Alright, I've had this on here about half an hour now, and the moisture is being evaporated out of it. This is something that can't be hurried, otherwise you'll start spattering the platinum group metals out of the beaker. So I got to heat it slowly until I get it bone dry, and then we'll get a weight on this powder. Okay, finally got a moment of truth here. And I come out to check on my mixed black PGM powders, and I got a broken beaker. I have never ever experienced a broken beaker like this. I think this stock pot series is jinxed somewhat. I've got another beaker here that I've written the weight on. It's 227.7 grams. And we'll tear the scale on that one. And then now we'll take the pieces of this broken beaker and we'll transfer the entire beaker into this, and that should give us the weight that we're looking for on the mixed PGM powders. Just going to put everything right on in there. Luckily I had a clean dish here, so all I got to do is transfer the stuff out of here into my new container, and I should be able to get a decent weight here. Alright, I've got 132.1. The beaker up here was 125.1. So 132.1 minus 125.1. See it there? That'll be, that means I've got exactly 7 grams of mixed PGM black powders in there. Okay, this will conclude part 14 in the stock pot refining series. I've got another mess to clean up. This one shouldn't be that bad. Fortunately, I had a clean dish out there on the heating pad, and so it'll just be a matter of getting this all in solution and then getting the bits of glass out of there. No problem. I've only got 7 grams of platinum group metals here, but that's quite all right. I mean, even if I just got 2 grams, the education that I've received so far from doing this series has been priceless. I'd like to once again thank Aquila Refining for the suggestion of boiling the PGMs in hydrochloric acid. That seemed to have done the trick for me. I guess I don't have a whole heck of a lot more to say about this. I'll continue in part 15. We'll get this squared away and get the metals, and then the next steps are just to get the platinum group metals out with ammonium chloride, and then take and get the palladium with the process that I'm already familiar with. And we should have some metal here very soon. The Stockpot series is coming to a close, thankfully. I'll be glad when this one's done. But anyway, this will conclude part 14. Thanks for watching.